everyone, I'm Lian, a PhD student from City University of Hong Kong. Welcome to my presentation about our position paper. It's a joint work with my colleagues Anxin, Zhou, Yifeng, Zheng, and my supervisor, Professor Wang. In this presentation, we're gonna overview an end-to-end encrypted crowdsourcing platform and talk about how to build such a version in a secure and trustworthy way. While crowdsourcing platforms are everywhere, when we talk about it, it's broadly defined for crowd data collection. It could be Mechanical Turk, where you can recruit workers working for you. Or like SurveyMonkey, you can collect people's opinions on different ways. While being popular, there are many security and privacy threats, according to recent news. Attackers, if they can successfully penetrate the platforms, they can gain access to plain-text data. While even the insiders, if they are not trustworthy enough, they can still gain access to plain-text data. So that raises a very big concern about how we can better protect the data. And in the meantime, many regulations also require the platforms to better protect their data. So for that purpose, an intuitive method, perhaps we can build an end-to-end encrypted platform to serve for that purpose. And by end-to-end encryption means that the generated data submitted to the data requesters, the whole data pipeline is encrypted, so that the platform has no way to obtain or simply test the data. While so-called E2E applications have been used over the past few years, there are many popular applications like Signal, WhatsApp, and Preview. And also, in the crowdsourcing domain, we believe that the importance of enabling encryption has been recognized by many research studies. However, as we show later, E2E alone is just a starting point. There are many remaining issues to be resolved. Well, for example, the first thing coming in mind is once we encrypt the data, how we can provide the same level data utilities in crowdsourcing. Well, this problem is about confidential computing, so we need to find a way to compute encrypted data. Well, from two different technologies, based on our overview about things we need to support, we believe that hardware-assisted designs may be more promising to achieve that. And because it provides a trusted execution environment, which can support original code execution, so that you can possibly achieve versatile data utilities as demanded in crowdsourcing. So this is the base that we plan to start to envision a crowdsourcing platform with built-in E2E. From here, what are remaining issues we are going to talk about? And this is a list about all requirements we need to support. From our point of view, they are important and should be fulfilled in the first place at such a platform. We're gonna start with the quality. Well, just like current crowdsourcing platforms, they need to deal unreliable crowdsourced data. Well, by unreliable means that the data quality needs to be checked. And there are many different ways to check data quality. A common method is aggregation, which is a simple idea. You assign a task to multiple workers and take the majority of their answers to as the final result. However, it's harder to operate encrypted data, and in addition, according to our investigation, current aggregations are not satisfactory. There are many rooms we can improve to further ensure data quality. For example, this reference mentioned truth discovery, also called reliability-aware aggregations. So what do we think the first thing we should do is to perform reliability aggregations over encrypted data. That means do it in the TE context. But I think TE is well known that it's not a panacea. It has many own limitations, such as limited memory space, side-channel attacks, and costly enclave interactions, which should be carefully considered for such a design. Well, this is quality assurance, a basic data utility in crowdsourcing. Next, we move on to more advanced data utility, data analytics. I think it's normal that when we collect high-quality crowdsourced data, the next thing is to uncover data insights by analytics. Well, as we can see, many of them can be done by statisticals, or we can say running SQL query in the database systems. So our next challenge is to support versatile data analytics over encrypted data. And we want to provide the same level data utilities to users. We need to support running SQL queries directly in the encrypted database systems. And ideally, if we can develop such a design that should have certain level backward compatibility, that would be our ideal case. So with the requirements, let's look at what are available so far in the literature. Well, as we can see, there are many proposed works about T-based database. I think they are very good cases for our start, and also mean that this area is really going to take off. However, there are many remaining issues to be done. Well, firstly, there are many security and performance issues. Previous works could reveal exploitable leakage profile, such as access pattern, key ordering, and the search path. And they may have low performance due to aforementioned limitations of the TE. Well, on the other hand, according to recent research studies, if we directly release the analytical result to users, it might leak private information of workers. So which should also be considered in such an encrypted database. So this is supporting versatile data analytics. So far, we have talked about a secure backend. But another thing which is largely overlooked by previous works, I think is equally important to enable such a platform. That is front-end data protection. Well, look at front-end, where users interact with the platform directly using their browser. But as we all know, there are many web attacks lying on the front end, such as phishing, injection attacks. So there are many possible ways that the data might be stolen without user consent, especially when the browser has installed untrusted extensions. Because they are usually granted high priorities, so they can easily access and modify data. So this is another concern that when we develop such a platform, we must take into account. And indeed, such importance of secure data collection at the front end has been realized by the community so far, not only by the academia, but also by industry. This is an example, I think. Lian is cooperating with producing the researchers. They try to build a secure data collection channel at the front end. In a way, they build a browser plugin that can isolate a data collection channel to define the malicious web elements. So that really gives us the insight. Perhaps we can also create an isolated environment for web data processing in the browser. And I think there are many possible ways to achieve that. Well, specifically, one of our preliminary works from my colleagues is about to build a software-based web enclave that exactly provides an isolated environment for web data processing. So we are going to follow the work and try to integrate it into our platform. Specifically, we will consider how to support complex web data processing in crowdsourcing, how to identify our data fields on different task web pages. Well, after talking about front-end data protection, lastly, we want to talk about an independent issue. I think it's very important not only in the plain text domain, but also in the encrypted domain. That is content moderation. Well, it's well known that moderating content is of paramount importance for many good reasons. One of them is to prevent the spread of harmful content on the digital platforms. Like recently, we have heard a lot of news about it's a must to build content moderation for long-term use. And actually, in the encrypted domain, this problem is more serious because the encryption is proliferating the spread of misinformation and pirate content. The problem here is that once we encrypt the data, the platform has no way to see what's going on. So how we can detect harmful content without sacrificing encryption? Well, this problem is quite new. So there are few research studies about that. However, they can still be classified into two types. Well, the first method is a reactive method. By reactive means that the platform relies on users to report harmful data, and then trace back the data source and forward path. However, this method assumes that users are trustworthy. It's harder to guarantee that actually. So we think that more efforts are required to ensure that users are always trustworthy. While the second method is a proactive method. I think it's a straightforward idea. Just borrowing the method from print as a domain, they use a blank list to check any following content. Perhaps we can achieve it in the encrypted domain. And actually, Apple has started to enable E2E content moderation at their messenger service with exactly blank list-based method, so called CSAM detection. Well, I think there are many issues we should consider. Just like any blacklist-based approach, it could be bypassed, or even worse, the blacklist provider could abuse it for malicious intentions. So how we can keep the blacklist fresh and up to date, and who is better to control it? I think there is ongoing debate where we can see how the literature can move forward. Well, at a quick summary, in this presentation, we talk about how to build a secure and trustworthy crowdsourcing platform with built-in E2E. We think E2E is just a starting point, and there are many remaining issues to be addressed. This is not a complete list, but I think these are very good cases, and they should have high priority to be resolved at such a platform. So finally, we would like you to involve our presentation, and we are happy to answer any question. Thank you for watching.